We're now going to do some review of basic trigonometry as well as look at 3 additional ratios you may not have heard of yet. So, as a reminder, we use trigonometry when we have a right triangle. And the phrase you may have heard before is SOHCAHTOA. And this is just a mnemonic device to remember what side goes with which ratio. And so what that meant is that sine is the ratio of the opposite side, over the hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. And tangent is the ratio of the opposite side over the adjacent. And let's make sure we can identify these correctly. So the hypotenuse is always across from your right angle. And then we need to have a little theta here. I think that got lost in the translation. So opposite from the angle that I'm given. And then the leftover one is adjacent. So I always suggest labeling my triangle in this order, HOA, because sometimes when we try to do the adjacent first, we make a little boo-boo. All right, so what you may not have heard of before are these other 3 ratios on the right side. So this stands for cosecant, secant, and cotangent. And I've written them next to their reciprocals. So the reciprocal of sine is cosecant, and you get that by flipping it. So instead of opposite over hypotenuse, it's the hypotenuse over the opposite side. Secant is the reciprocal of cosine, so that means I will flip my cosine ratio to make it h over a. And tangent will flip to be a over a. The other way I can write this would be 1 over sine, 1 over cosine, and 1 over tangent. That will be helpful in a second when we talk about calculators. And so we want to be able to go between these 2 different ways of thinking about things. So on our calculator, you may have noticed we have a sine, cosine, and tangent button, but we do not have a cosecant, secant, and cotangent button. So what we have to do is use those green ratios I wrote on the top. So if I want to find something about like cosecant of 32 degrees, I would have to do 1 over sine of 32 degrees. So this is different than doing inverse sine. So when I do inverse sine, what's in here is the ratio, and I'm equaling an angle. So we have to keep the difference between the inverse of sine and the reciprocal of sine. Those are 2 different things. So if I want to find any of these reciprocal ratios, I would have to do 1 over the corresponding ratio. Normally, we won't really do that, but or at least in this unit, we'll look at solving some different things in the spring, and we might need a little bit more. All right, so when we are solving for a side of a right triangle, you've been doing this since middle school probably. If I have 2 sides of a right triangle, say I have these, I can find the missing side by doing Pythagorean theorem, a squared plus b squared equals c squared. Sometimes I'm given my hypotenuse, so your hypotenuse is always your c value. So say I have this equation, then if I'm solving for that missing side, I could call it a or b, it doesn't matter. And we would solve and get that. Typically, at least right now in this unit, we'll want to keep stuff as radicals versus changing things to decimals. But it kind of depends on the problem. We'll look at a couple examples. So here's a very typical problem where I want to find the exact values of all 6 trig functions. So that means I'm finding sine of theta, cosine theta, tangent theta, and you have to have the theta. We'll get to some other things in later units where I actually have 2 angles going on, maybe alpha and beta. So you want to make sure you always have to be doing an angle because it's the ratio of that angle. So don't get lazy, always put a theta. All right, so in this one, I am going to label my side. So I have H, O. So I can start, I have sine, so 5 over 13. And if I flip that 13 over 5, I have cosecant. But to find all the other things, I'm going to need to find my adjacent side. So I'm missing a side in a right triangle when I have the other two, so I can do Pythagorean theorem. So a squared plus b squared equals c squared. Remember, the hypotenuse is always your c. And when I solve this, I'm going to get 12. This is something called a Pythagorean triple. So if you can memorize, it's 5, 12, 13. It can save you a lot of time. Otherwise, prove it to yourself with the calculator. All right, so that's 12. So since cosine is adjacent over hypotenuse, this will be 12 over 13, which means secant, flip it, is 13 over 12. Tangent, opposite, 5 over adjacent 12. Flip it, 12 over 5. All right, so these next two examples, they don't give me a right triangle, so I'm just going to draw a right triangle. And I can choose wherever to put my theta. I like putting it down here. Doesn't matter. And now what I'm going to do is label my HOA, H-O-A, and that is going to be the same no matter what I'm given at the start. So now I'm going to look, and what I'm given is cosine, which is adjacent over hypotenuse. So I'm going to label my adjacent side with 9, and my hypotenuse with 15. And so I still need to solve for my opposite side. So a squared plus 9 squared equals 15 squared. And when I solve that, I get that a is equal to 12. So we're going to find our 6 ratios. So sine of theta, we said our O is 12. So 12 over 15. Cosecant then, which I can't spell, that's fine, I do that a lot, is 15 over 12. Cosine we were given, so that's kind of the easiest one to start with. So secant is going to be 15 over 9. Tangent is our opposite, 12 over adjacent 9. And cotangent, we flip that, so 9 over 12. And notice I didn't reduce any of those, and that's totally fine. So if you think that you've got the hang of it, go ahead and pause and try this one on your own. Otherwise, we'll make our triangle. Sine is opposite over hypotenuse. Still need to find the last side. I'm noticing this is not a happy little Pythagorean triple, so sad face, I am going to have a radical. That's okay. So I get square root of 120. Once again, we don't need to simplify it, just leave it. That's fine. Nobody cares. All right, sine of theta. So opposite is 7 over hypotenuse. They gave that to us, so I could have just looked at what we were given. Cosecant, we're going to flip that. And now everything else, I'm going to have that happy little radical. So cosine is adjacent over hypotenuse. Secant, you flip that. So 13 over square root of 120. Tangent is opposite over adjacent. And cotangent, we flip that. Next, we're going to look at what happens if instead of just doing this little acute right triangle, what if instead we plop it on our coordinate grid and we have it in different quadrants. So that's what's coming up next.